So next we're going to talk about one-sided limits. So I'm going to just start with the notation. The limit as x goes to c, and there'll be a plus here. When we write a plus, what we mean is we're taking the limit from the right. And the limit as x goes to c. Now if I have a minus here, what I mean by a minus is you're looking at the limit from the left. So we're going to talk about these with a particular example. Let's look at the function the square root of x. And you can graph this function. Remember, you can't take the square root of a negative number. So the graph looks like this. Now, if I'm taking the limit from the right of 0, you're only going to look at numbers to the right of 0. So here is x equals 0. You're only going to look at the right-hand side. So if I look at the right and I go down and I get closer and closer to 0, what are my y values getting closer to? They're getting closer to 0. On the other hand, if I look at the limit from the left of 0, well, now I'm going to go to 0 and I'm going to look at the left of 0. So I'm going to look at the left of 0 and there is no function there. I don't have a graph, and so this limit does not exist. Okay. So when you're looking at one-sided limits, what you're doing is you're only looking at one side. You're either approaching from the left only or the right only. Let's look at an example. I want us to find the limit of the function the square root of 4 minus x squared as x approaches -2 from the right. So the first thing we're going to do is we're going to graph this function. And you may or may not recognize this graph. So let's start by saying y equals 4 minus x squared. And I'm going to rewrite this equation so it's something that's more familiar. We're going to square both sides. And if I add x squared to the other side, this is now, should be familiar. This is the equation of a circle of radius 2 that's centered at the origin. But this graph is not the entire circle. So if I go back to my original equation up here, you'll see that y is a square root. Well, that means y can only be positive. And so it's only the upper half of the circle of radius 2. I'm going to try and draw a decent looking circle for you here. Radius 2 centered at the origin. And now, what did it want me to find? I was asked to find the limit as x goes to -2 from the right, so it would be a plus of my function. So let's look at our graph here. -2 is located right here. I'm going to approach -2 from the right. So look at my graph. as I approach from the right, what are my y values getting closer to? They're getting closer to 0. So this limit would be equal to 0. Let's look at one more example here. So before I do that, let's define this new object with these two square brackets. What this is equal to, it's equal to the greatest integer n such that n is less than or equal to x. You can kind of think about it as like essentially rounding down. If I take 2.5, what would this be equal to? It would be equal to 2. And if I do a negative, negative 2.5, remember it's negative, so rounding down, it would become a negative 3. So let's look at this next example. Let's find the limit of the greatest integer function as x approaches 0 from the left and from the right. So we need to start by graphing this function. So when I round down the number 2, it would stay the same. But what happens when I round down a number between 1 and 2? It would round down to 1. So all the numbers between 0 and 1 get rounded down to 1. But also if I round 1 down, it would be 1. If I take the numbers between 0 and 1, they would round down to 0. And 0 would remain the same. So you're getting this kind of step-looking function here, made up of all these pieces that look the same. Let me do one more piece. Between 0 and negative 1, it would round down to negative 1. So now that I have my graph, let's talk about the limit as x goes to 0 from the left. So as I approach, here's 0. I'm going to approach it from the left. It's always, my y values are always negative 1, so this would be negative 1. Now if I approach 0 from the right, look to the right of 0. Here, my y value is always 0, so this limit would be 0. So there are my two limits. So the last thing I want to do in this video is I want to connect the idea of one-sided limits to regular limits, and that's through this theorem 210, which says if the limit exists, if and only if, my two one-sided limits are also equal to L. C from the left is L, and the limit as x goes to C from the right is also L. So if we look back at this previous problem, the limit as x goes to 0, these two values here were not the same. So I now know that the limit as x goes to 0 does not exist.